Hello everyone, we are back. It is very late into the night, almost 9 p.m. I don't know how long this video is going to be, but I wanted to keep pumping videos. This is the third video straight about this P4th thingy. And in this video, as I mentioned in the previous one, I want to start like playing a bit with assembly. So we already went through the like high level stuff with the more or less syntax tree. Then we went to bytecode. That is not really needed because fourth is already by itself super similar to bytecode, so I don't think we will need that. And now I want to like have a proper fourth system with some assembly instructions. I want to JIT compile stuff and I want to emit instructions into some memory region and execute that memory region. So let's just create like a folder here. Call it old, move everything here, and we can work like in a proper system now that we have studied the idea. I'm going to call it main because I still don't know what I'm going to call this language. Here, let me just copy all of this because this is still needed. Fourth is nonetheless still a line-based language. So let me just copy all of that, like so. And here, let's try to have something very, very basic. So in fourth, if I'm not mistaken, the input buffer actually has a very specific name. So fourth TIL or something. That's not what I wanted. Fourth language buffer. There's like, that's not what I wanted. So line buffer name. There is something that actually, like a variable that actually represents. Let me see if AI can generate. Terminal input buffer. Okay, terminal input buffer. So we can call it that. So we can start naming stuff the same way that fourth names them, or we can just call it line. Do I want to call it terminal? Well, this is more like a buffer. We can call it line buffer. Do I want to use camel case? Okay. Anyways, call it line buffer. I think it's because terminal input buffer assumes, well, but this system is going to be used from the terminal, right? So let's call it, yeah, let's give it the same name. So terminal input buffer. Fourth language, what is the size of terminal input buffer? What is generally the size of this? Let me say programming language. Otherwise, this is going to be, but the size can vary depending on the specific implementation. Yeah, that's what's the typical size? 256 bytes. Well, that's very little. Let's say 1 kilobyte for now. So yeah, we can just say tip size. Oh, this is fine. Here we can say 2024 because we are in a modern system, so there is no reason to not use it like that. We don't need any of these. Here we're not going to have like a prompt. We're going to have something very simple. And I can like change this. So force language, like name of word that points to the next word, right, or something like that. Next input word or something. I know all of these kind of stuff, they have proper names in Force, and I want to like try to copy them as much as possible. It's called next. Okay, we can call it next. So we can basically have words, or in this case, it's going to be a function. It's fine. We can say const char, and we can call it next. So I want to like yeah, let's say like this, because I'm still inside C. So yeah, and this is also going to be static. This one is also going to be static. I can, yeah, this is not constant, so I can say something like that. And the next thing is basically just going to give me yeah, so basically while words okay, so I can say static char. I can have like a global variable, something like this, that is initially null, and then here I need to check a few things. So if next so while word has something, yeah, so yeah, so let's say something like this. We need to do this. Here we need to consume it from the tip, from the terminal input buffer. Then we can assign it there. I don't even know if I need this, to be honest. Right, but okay, yeah, I probably don't need it. I was thinking the wrong way. So we can assign it there as a result. If the result exists, we can return it. Otherwise, if it does not exist, right, we need to read it like that, like this. So we need to read the another line from the terminal input to the terminal input buffer, and this actually needs to be a while, right? So while the word does not exist, we basically do this. So let me think if this is actually right. So we try to parse a word or take a word from the terminal input buffer. Okay, we try to do that. If it does not exist, so the terminal input buffer no longer has any words in it, we get a new line and we try to extract a word from that line. If that line still does not have words, we keep parsing it like this. Yeah, it makes sense. But in this case here, I need to use this version. I cannot use the other version. I need to use this one, right? Oh, actually here, no, it's correct. Yeah, here I assume I need to read from there, but here I need to reset the entire thing. So yeah, like this. And at the end, I can return results. So this thing guarantees me that I'll always have, I can always call this and have a next word. So the word that's basically being parsed, right? The word after this. So, but I need to check for end of file, right? I need to check if the current stream has ended. So what can I do? So if I do man str, oh, actually fgets. So how do I know when the stream has ended on error, or when end of file occurs with while no character have been read? So I basically need to do, but how do I know if it is an error? Well, it doesn't matter, right? It doesn't matter to distinguish between an error or end of line or end of file, because I can just say this. So if this doesn't do anything, we can just return null, right? We can literally just return null, and we instantly know that there was no next word, right? There was no next word. And here, for the sake of it, we can have, I'm using like, let me simplify the code. So I'm using static, it doesn't matter, I can optimize it later. Here I can say size t, and I can store the current line, just like for reporting errors. I think it's easier. So here I can say every time I enter this loop, I increment it like this. And this actually starts with 1, because yeah, this actually starts with 1. Okay, so yeah, I don't know how useful this is going to be, but I'm starting the current line that we have, right? It may be useful to throw out errors. Cool. So now let's try to have something simple. If I call next and I do something like this, so I got the next word and I just print f that word, it should just output the first word that I inputted into the file. So if I do gcc -o main.c w all and std c99, and then I run main, and we have some errors. I have here print f here. Oh, this needs string .h, I believe, probably. I need anything else? Oh, yeah, of course, this is not a constant. Segmentation fault core dump. Oh, I see, I see. So, oh yeah, that's what I was trying to do previously. I need to keep track. I need to keep track of that. So, well, I can actually just say the following. If the line is equal to 1, so this was actually quite useful for now. So if I'm reading the very first line, oh no, it's not useful. Yeah, I still need to, how can I even do that? Well, let's include standard boolean. And the only thing like I can think right now is like is first or something. I really cannot think of anything else. So here I set is first. If it is first, then I pass tip. Otherwise, I need to pass null. And then I need to make this first equals true. Is there a better way? Actually, it's false. Is there a better way? I don't think there is a better way. Like this is more like like, you know when you have like those classes with the getter pattern and you need to instantiate it on the first call. I think this is one of those scenarios. So yeah, like this is a self-contained block of code, so I think it's fine. And like this piece of code guarantees me that every time I call the next word, I'm gonna get the word. Okay, that's it. I don't need to worry about it. So if I do this and I do bar, or actually foo bar bars, this should print foo. Okay, it works. And if I do other stuff, actually, well, I need to do the following. So if I do while true, and I just wrap this inside this while, and I try it again. So just to make sure that the code works for multiple lines. Foo bar, yeah, and bar buzz, and 1 2 3 4 5 6. Okay, control yeah, control D didn't work, but I can add that feature later. Okay, so now we have our terminal input buffer. We read stuff into the terminal input buffer, and we then extract words from it, right? And we only like read more lines once the words have fully exhausted, right? Once the words in that particular buffer have fully exhausted. Right, so let's try to have something very simple and try to actually emit assembly code. So we will need like a memory region where we can store the actual code. So this fourth I'll be writing is like procedure threaded code or something like fourth, because there are many ways to thread procedure threaded code or something. Many ways to thread the, yeah, there is indirect threaded, then it's direct threaded, subroutines, yeah. So I'm basically going to use the native call, instruction call from x86, 64 to actually have the all of the different things. Does this explain all of the different threading? Okay. I wanted to like forth programming all threading mechanisms. I wanted to have like a good link to show procedure. There is like nowadays it's super hard to search stuff on the internet. Like all of the results are always bad. Yeah, I don't think code together. Yeah, basically it's how do you teach all of these different procedures. But I wanted to show you something because there are many ways to thread. Describe threaded software. Okay, I'm gonna like force indirect threading. This is the last attempt I'm gonna make. Maybe the GNU forth has, no, it does not have anything. Okay, it has this. So it's direct threaded, threaded, indirect threaded. Then there is like the subroutine threaded or something and whatsoever. So each one of these mechanisms, like the user is going to be completely unaware of whatever is happening underneath. It does not matter. But there are many ways to actually combine these words and the bodies of the words. That's what I'm basically trying to say. And what I want to do in this implementation is the fastest method, which is basically using the native instructions for call and return. So all of this for me to explain that. What I want to do now is to basically have a way. So let's implement. So this is basically for like input, right? I'm not going to comment because I don't need to, but now let's handle the primitives, like the built-in words, right? So let me think about this. Let me think. What do I want to do? So if I do volatile, let's say native or something, or instructions. I don't know, I need to think about a better name. But here I can add the ASM stuff, right? And this is because this is complaining because I'm using, yeah, VS Code inside Windows. So yeah, it's going to complain, but this should compile inside Linux or yeah, so let me try to, so GCC underscore ASM underscore. Let's try to figure out how this ASM directive actually works. So it doesn't have, well, I thought it had. That is very strange. I thought it actually had that stuff, but it doesn't. So can I do something like this? Volatile ASM. Oh, I didn't say the file, okay. Declaration specifier. Yeah, and it needs to be volatile so the compiler doesn't like remove the instructions, because I basically want to copy the instructions at runtime, but I need to have some way to point at them and actually have them in my thing. So yeah, we need to use volatile so the compiler does not discard them. But how do I even? Oh, it's the other way around. So ASM, is this C even? I thought it was like ASM volatile. So this is what you're telling me to do. Is this going to compile? Still need to. Yeah, this does not. Yeah, there is something. GCC C. I want it in C. So if I copy this, is this going to compile even? This is very simple. Or does it need to be inside a body of a function? So let's put it inside a function. Let's say void f. It probably needs to be inside a function, right? So something like this. Implicit declaration of function asm. So I always thought it needed like this stuff. Okay, so it worked. It worked. So it needs to be inside a function. And here, I need to mark this as volatile, right? Is this going to compile? No. Does volatile need to be here? Yes, okay, so this compile. Can I also mark this function as volatile just to be 100% sure? It's probably the other way around. Or is it even possible to mark? Probably not. Okay. Let me just confirm. C volatile function, because I need to make sure that this specific block of assembly does not get changed or removed. Sure, but can I mark a function as volatile? It's only used for... Okay, so it's only used for variables. So let's assume that the compiler is not going to like manipulate the function. Okay, let's assume this actually works. So here we will need some things. First, we will need to mark export a few symbols. So we need to say global. And what do I want to export? Let me say I want this first instruction to be like a literal, for example, like push literal. Well, to push a literal value, I'll need to generate... Well, that's actually a very hard instruction to implement, but let's say. So this is going to be lit begin, lit end, right? So we need to export these two symbols. Here I need to lit underscore begin, and I need to begin the label. Then I need to write this, and I need to get like some refreshing on x86 64 push literal into stack. Okay, let's see how we do that. Okay, but the push instruction, well, yeah. That's actually very interesting. So my initial idea was to basically have these kinds of blocks. I just needed to copy paste them, but I didn't actually this problem didn't actually came across at the time I was thinking about this, because here we'll need to inject dynamic data, right? We cannot like have this at compile time. We still need to change the assembly at runtime. So let's simplify this a little bit, and let's treat like dupe, for example. Well, I think I want to do this. And dupe is basically going to like x86 64. Like I want to move, because I want to have the stack separate, the data stack separate from the normal stack, because I'm still going to use the normal stack as the return stack. Move, so I want to move value into memory, basically. Is this the reference manual? Okay. Integer to register, register to register, register to memory. So that's it. So let's define like a standard. So the ABI for Windows and systemd, I want to like basically just get like some free registers that I'm almost certain that the system is not going to use. Yeah, application binary interface. Let me get, oh yeah, I forgot, for x86 64. Yeah, but man, isn't there like a table? Why is everything so... Okay. So the registers are considered volatile, colors saved. So I want the Kali saved registers, so they are non-volatile, and I have all of these. Then I probably don't want to use these registers. These are probably already going to, like, the RSP is probably in use for something. So I probably just want to use these registers, these generic ones. Yeah, so the first 6 is a static chain pointer in case nested functions. Exactly. So basically what you're telling me is that the R12, 13, 14, and 15 are never used, right? So RSP is not used here, but of course is a stack pointer. Then RCX is there, but it's volatile. If Kali wishes to use registers, it must return the original value before returning control to the caller. Sure, but can I reserve them? Can I simply just reserve the registers and just make sure that the compiler is never going to actually use them for anything? Because I know that when I call a libc function, since these registers is called is saved, I know that that function is going to return me whatever value I put in there, right? But I don't want to, in every single instruction, to manage all of these like preludes of pushing, popping, and saving registers. So let's do the following. Let's assume that in here, is there any way to reserve a register? I think there is. So if I say something like register, I don't know, uint ptr, because this is always the size of a word, and I'm saying R12, and this is basically unused, this is just to reserve it. And I say as like this. How do I even reserve? Isn't register a global scope declaration? May not have this storage class. Okay, so let's maybe ask a Clanker. That.ai. Start fresh. God damn. Okay. How do I reserve a register in C GCC? Oh, and I can even pick the model. Okay. I don't even know. I never used this one. Let's try it. Yeah, but I want to reserve a very specific register. Oh, I need to use this. User compiler attributes. Okay, that's very interesting. So if I do this shit, but how do I guarantee? Does this guarantee that what was it? EAX is not used anywhere else by the compiler? It's a very, very important question, because if that's the case, then we are basically solved, like we solve all of our issues. Okay. In that case, okay, but if I'm using R12, because it's what if I use R12? Because if the ABI, like, is a different story. Call is save register, which means that it is preserved cross function calls. This is in contrast to EAX, which is volatile. Sure. Function calls, unless the compiler has very good reason to split the value to memory. Okay, but at least we have some level of guarantee that it's going to be more or less reserved. Okay, so if I do something like this, and I say that, yeah, but register, let me say, if this is compiled, register name, and if I do it like so, okay, so I basically need to, well, but this was ignored. Why was this directive ignored? Let's ask the Clanker. But I'm using register, not... Oh, it's not a send, it's not... What is even clovered? So this video is just me talking to a Clanker, I'm seeing. Very interesting. All right, so basically, let's try to... I want to have as in my C code to be able to compile fourth words, and I basically want to use mem copy to copy the memory into, or actually the blob into executable memory completes this definition. R12 is the top of, well, yeah, R12 can be the pointer to the second element of the data stack, and R13 holds the value of the top of the data stack. Let's see if the Clanker is able to fix all of this. Because like when we export this kind of stuff, then we can do something like this, mem copy, and we can literally just copy to some destination, and the size is literally just going to be, like if I have something like this, it's going to be end minus begin, right? It's very simple, because here we can just say extern something like int that and that. So, and these symbols are going to be exported by the assembler, right? And we can extract them. Here we should have something like an implementation, and then we have this label, and whatever comes in the middle, we can extract the size and the number of bytes that that specific blob of instructions took. Because that's another issue. Like in x86-64, instructions have different sizes, so I cannot even rely on that, which is very, very strange. Okay, so yeah, that was my idea. Reload. What is even R13 reload? What do you mean R13 reload? What the? Anyways, and R13 holds the value of the top of the data stack. Sure. Yes, we are going to do this afterwards, but I don't need it. But this code is not correct. It starts right away. Save the top. Okay, so let's have the standard. So R12 points at the second element of the data stack. Is there a name for that? Fourth second element of data stack name. I cannot type name. I know, because like fourth has a name for everything, and I just want to use the standard names. Cat10. Let's call it SP or something. Yeah, it's fine. So that one is stack. Wait. Second. But does it make sense for it to be the second element? No, it can be the top of, yeah, stack of, yeah, it can be the top, because we can point at the top and we just, well, but when we move it, let's figure it out while we're programming. So R13 is going to be the top of stack. It's the value, right? And so here the Clanker suggested something that is stupid. Assume R12 is the pointer to the data stack, and R13 is the top of the data stack. Well, your job is to duplicate the top of stack, i.e. Move the pointer by 8 bytes and copy top of data stack, top of stack, something like this, because it still needs to do operations, right? It is not even properly doing stuff, which goddamn. Why do you still need to load it into racks? So these clankers are very, very dumb. So I can basically, let's base ourselves. Yeah. So okay, so it needed 3 times. Okay. So this one sub q, it does sub. My stack is going to move yeah, is my stack going to move upwards or downwards? Let me think. Yeah, it can move like up. Well, it doesn't matter here. So move R12 to new location. That's fine. And then okay, this is the code that I want. This one is like, it makes more sense. But here, instead of sub q with the value 8, I need to do the following, because this is going to subtract. I need to add q, right? I need to add 8, which is basically 8 bytes, is the size of a word, to R12, which is the pointer of the top of the stack. And then this one, move q, is going to move, well, but it's not really, well, yeah, because this is a source. This is in like AT&T syntax. This is a source, this is a destination. Okay, yeah, this is going to move into that specific memory region, which is what we want. Cool. So let's try to do the following. It has right here, it has a pretty decent thing. So if we do R12 is the stack pointer, R13 is the top. Yeah, sure. So the top can be 20. It can be 20, but here we need the data stack, right? So we can here we can define our stack, and our stack is, it needs to be something like uint. It doesn't matter. Yeah, in this case, this is specifically to 64-bit system. So yeah, you can say uint ptr, and this is going to be my stack. And let's just say that my stack for now is going to be 256 words. It's fine because like we want to use the cache, right? The L1 cache, want to keep that there. And so here my R12 needs to have a pointer to that. And so if I dupe this and then I know I only moved it once, right? So I can basically just say, okay, print the value in these two particular locations in stack 0, which should have trash, or 0 in this case. Yeah, it should be, because we first move and only we first like move the pointer and only then we copy the data. Maybe we should do it the other way around. We should like, well, but it doesn't make very much sense, right? Well, I need to think about it. So if like, I don't even, yeah, it's not, so this should be just an integer. Okay. It needs standard int. Fine. weren't you complaining? Oh yeah, because it didn't have a definition. So yeah, it needs a long. So why? Implicit declaration of dupe. Yeah, we can call it dupe here. Um, assembler message junk at end of line. Oh yeah, because there, but oh, I see. So here it needs to actually be. I need to add the new lines, of course, because this is literal assembly code. So I need to add all of this. Okay. Bed register name. So I assume you only want one of these. I presume. And then we have segmentation fault core dumped. Cool. So, okay, let's copy that and let's add it to move it to the Clanker. The Clanker will most certainly know what to do. The Clanker is our friend. I don't like. I don't want to read this. Like this is super late, 9:30 p.m. Yeah. Oh, I can do something. Output operands, input operands, clovers. So this is like, I don't even know what this is. A comma separate list of registers or other values changed by the assembler templates. Oh, here. Beyond those lists as outputs. Okay. This is a literal string that is template for the assembler code. It is a combination of fixed text and tokens that refer to the input, output, and go to parameters. And then here, the C variable is modified by, okay, so this is, okay, a comma separate list describing the C expressions read by the instructions. Okay. Sections, okay, volatile, and these confined forms that compiler may perform a jump. Okay, so go to this is actually important. It's actually important because when we have like conditions, and ifs and all of that, we may want to add this quantifier. Anyways, what are you complaining? She's int variables, but are oh, yeah, yeah, that makes total sense. I totally forgot it. So, but yeah, it's not. It's completely like hallucinating. It still does. We may want to change to a different Clanker while I read the documentation. Yeah, here they assume, of course, that's what I was talking about. Like is there any other way I can well, I can initialize this with assembly code, right? With assembly volatile code. Compiler project RT is not a standard. Okay. So yeah, that's what I want. So here, instead of doing that, we can use this. Is just for test. It's fine. But here, let me try to understand. So it moved. Why did it move? So you are telling me that C code can extract this shit from there. What the fuck? Let me ask it to explain. Explain this. Yeah, that part I know. Exactly. Then this first of the first input operand. Okay, so this is the first Ah, I see. I see. Because this is not a dollar, this is a percent sign. Okay. Um, into first of all, into the register to specify a register name. This is not going to compile because it needs that, I think, but okay, fine. Then then that's the same. This is output, okay. This input operand should be loaded into registers. Okay. R12, R20 register is specified that R12 and R13 registers are modified by the assembly code. Okay, that starts to make more sense. Okay, so that actually worked. That actually worked. Because if I have like 30, it worked. Cool. So if I do multiple times, and I print here, I should have a bunch of 30s. Yeah, it's working. It's working. So here, in that case, I should also have that directives, right? Here, this is output, right? Output operand list. Okay. Then here I should have the inputs. I also don't have anything, but here for the cobbler or whatever is that name is, the clovers, yeah, the clovers, I should have something. I should have, because R12 was modified. R12 was modified and R13 were also modified. So this should be my code. Let me ask something for the Clanker. So now assume I am compiling a words a little. I need to copy a block of machine codes and adds or dynamically add the literal number needed. How can I do that? That is a very interesting question to make to a Clanker, because this was the initial question I couldn't really figure out. Like, we could do this, but this is just, well, I don't really know. Yeah, but this like forces me to manually patch it. I mean, it's not that bad. So create codes. It gets a literal. Here we manually like do the opcodes and everything. Okay. Okay. Can I still use as just to simplify, because if I start to write like machine codes by end, it's going to be quite something. How do you even know? This is not going to work for sure. Of course it's not going to work as expected. Once I copy the codes, the literal should already be there. Doesn't this approach isn't this compile or something like this. Like, I know I need to patch something. I just want an easy way to patch the correct place, because all of these instructions have different sizes and everything. Oh, it's actually it's yeah, of course it's I know that. What the fuck are you even talking about? If you want to store the generated machine code in a buffer, you can use inline assembly with the memory operands. What are you even talking about? No, I need to have the assembly block that I can patch with my literal, and then and then copy, right? I was reading what the fuck it did here, but it still tells me to do this. Jesus fucking Christ. But can I have, instead of the byte array? That's the whole point. I'm asking you. Jesus Christ. These clankers are very frustrating. I must tell you. But this immediate, okay, but this is for immediate 32, yeah. So this is just, god damn. Did not store anywhere. To store the generated code, self-modifying code. Here's example. What the fuck are you even doing here? Still it, of course. Best approach would be to define the assembly code as a template and then patch it with the literal. Let's try to, okay, let's try to do that in that case. It may work. I don't know. I don't know exactly how GCC handles this kind of shit. So let's say this is a literal. I have int64t and have the literal. And here, why? That is very strange. But can't I? Use labels to measure the block size, because that's the issue with this kind of stuff. Like, I don't know exactly what GCC is doing with this shit. I don't know, because it needs some kind of code to put stuff there, right? Or is it simply like copying and patching the self-modifying, like here like explain it and why we need codes in here in there. Like, that's what I'm not understanding. Why do we need to pass code inside this shit, right? It should be independent. It should be independent of that. This line moves the immediate value. The fuck was he? I don't even know. So it's moving this byte. Oh, I see what it's doing. It's trying to write machine code. Fucking hell. Code. Yeah, it's writing fucking hell. That's not what I want. Fucking damn it. No. I want the assembly with some mock literal that I can then replace by what I want. Now I understood what the fuck he was trying to do. Like, it made no sense. So basically what he was trying to do, it's basically, these are just the instructions, right? And then just write shit into the fucking Jesus Christ. It's not being able to generate fucking elements. Okay, let's just try to do our thing. So this is lit begin and lit ends. Begin, lit ends, and we need to have them. Right, something like this. And here, so when we get a literal, we basically need to move Q. So let me get this. Move quad word. So it's always going to move a quad word. It's fine. So this is, I need to go back to AT&T syntax. So this is the source and this is the destination. So when we want to push a literal, right, we first need to copy the top of stack into the stack, right? Into the stack. Then, but do we want... Yeah, so we push that, it's fine. Then we increment the value, so the pointer. And then we need to move a literal. And what's the size of a literal? There's no literal here. So let me go back to the Clanker. So it uses move L, but okay. Move Q x86 64 literal. Or immediate. They call it immediate, right? I think they call it immediate. Okay, but there is no immediate here. x86 64 immediate. I don't know how to write, fuck. Why can't you? Okay. Maybe Stack Overflow is actually useful. To run into the 15 byte upper limit on instruction lengths pretty easily. So there is, well, immediate, yeah. Huh. Let me ask the Clanker. So x86 64 move immediate 64 into memory. Is there an instruction to do that? Yeah, we can do that. However, this instruction is not available instead. So this is going to move that. Okay. So I first need to move it into a register. Is that what you're telling me? Let's try to search for this instruction. Into a register. But, okay. There is nothing here. Well, we can try it, right? We can try it, why not? So if we do this, and basically, so what did I want even to have here? So this one is copying the top of stack into that, fine, we increase the pointer, fine. Then here, we need to move some immediate, we can say 0, into, well, yeah, we want to move it into a register. We don't need to move it into, yeah, it makes no sense. We want to move it into a register. Yeah, let me just double check. Move immediate 64 into register. Move up ABS. Move ABS Q. But, well, what's the difference? I'm gonna keep moving ABS Q. But now I need to know where the fuck I can patch, right? Where should I be able to patch? Fucking hell. So let's do the following. Yeah, but here, let's just start code this 42 for now and just test and make sure this actually works. So I'm gonna not have this. I'm just going to the, okay, this is a literal. Fine. Oh, and this one, yeah, let's ignore this for now. So this is going to push 42. And then I'm just going to duplicate it a bunch of times. Yeah, why do you need... Oh yeah, I don't need that anymore. And I can remove that. So this only sets the stack pointer. Fine. Operands. What the fuck did I even change? So it's complaining about this one. Operand number out of range. What are you even talking about? Okay. Let's ask the Clanker again. This is a very like Clanker focused video, I must say. I was not expecting to need so much Clankers. Yeah, it's something with the syntax, and I'm super unfamiliar with these kinds of guys. Any output or input operands, but you are specifying clover ratios. The correct syntax for case would be okay. Ah, yeah, but push Q is going to push to my stack, to the default stack, not my stack. So let's try that. I don't even know why that's needed. I need to read the documentation. No, it's still complaining. Still complaining. So if I remove this, are you going to still complain? What are you fucking talking about? Oh, it's complaining here. So this code, what the fuck is going on? So if I don't do this code works. Okay, fine. So here I'm pushing the stack pointer into R12, and R12 is our stack pointer, right? Then I would do lit, but lit is doing stuff that it shouldn't, because here what do we do? So here we move this is the source, this is the destination, fine. We copy that. Well, but if the stack is empty, so let me think about it. Well, but we either way we need to save the top of the stack, right? So if we save that and then we add Q, it feels that it's correct. Let's, why is this printing 004242? Is it like with the size of the words or something? So stack, oh yeah, increments 42 for 12. Yeah, it makes sense. Yeah, I must not forget that this is the second value of the top of stack. This is going to be confusing, but yeah, let's try to keep this more or less efficient. So now I still need to patch this shit, right? I still need to patch this shit. What can we do? I can okay, add the ability to mem copy this block. Okay, just to see how it does it. Is there any efficient way? So yeah, it does that. So we this is, yeah, this is more like a shard, and all of these are pointers actually, right? Yeah, these are basically all pointers. Cool. And here, let's do the following. So let's print f. Let's print f the following. So for size t, this is not, yeah, this is actually a sharp pointer. Let's call it c is equal to lit begin, and C is less than lit end, we can do C++. Well, but this is, yeah, exactly, fuck. So we need to dereference it. So char C is equal to lit begin dereferenced. Let's do the following. So size t I is equal to 0. I is less than lit end minus lit begin I++. It's easier. And here let's just print all of the bytes that are in memory. So here I can just say lit begin at this index, and I can just do that. What is this going to, okay, it's segmentation fault, fuck. But why do I have a segmentation fault? Shouldn't this actually work? So if I get this and I print my lit begin and lit end, right? Is this still going to throw me a segmentation fault? No, it's actually, so these pointers do in fact have some stuff in it. And if I dereference it, so is the issue that I'm dereferencing it? Yeah. Oh fuck. Oh my god. There I was not counting on this, so I don't even know if this is going to be possible, this idea. I am getting seg faults when the referencing with the etc. Maybe we can mem copy, but we cannot like, but well, but it makes no sense. Because if we can mem copy, because here, so this is a block. Here they cast it there. Huh. They're actually labels, sure. So they, oh, I still need to do this kind of shit. When I used to use a linker script to define the addresses. So I still need to use like this linker script. Or a simpler way is to use inline assembly to store the addresses of these labels in variables. But aren't these symbols filled with the correct addresses? That's another question. Okay, so why can't I? Maybe I cannot, maybe I need to do the following. So I just need to define this as char, right? And yeah, if I take this, let's see how it goes. If I take this, you can delete all of this shit. So we have pointers. So how can I mem copy the data between dup begin? It's like I'm having, like, I don't know if this memory is protected or something. What the fuck is, okay. I don't know, the Clanker just had some issue. Yeah, it just tells me to do let's try that, I guess. Let's try that. Because here, let's say, this says this sheet. Okay, so let's assume this is the thing. So if I do this, and then I just have some block, but this needs to be, okay. Let's have some block. I still need to create a executable page. 64 bytes should be enough. And then I do this, right? Then will I be able to traverse this clock and print the bytes? Is that a possibility? Okay, I can do that. I can do that. So if this is unsigned like that, oh, must be that. Okay. So 73, huh? Oh, but these are bytes. What is the stuff like the printf bytes formats? I just need the byte stuff. Oh, I can print like a character, right? Or X, I could print X. Let's try X. Yeah, still quite a bit ugly. If I cast this to char, it should like, no, it's still quite ugly. Here they suggested HHX. I shouldn't need to cast it. I just want to make sure. Okay, this is what I wanted. So, I'm gonna ask, like, okay, let's see if the Clanker does this. Give me the machine X codes for this. I just want to double check that I'm copying the correct thing, right? All right. So this one, 4883C4. I got fucking hell. I got something completely different, but this could be like little engine. 4983 C4 84D. Is there only 4D in there? Not really. So I'm doing it for dupe. Yeah. Why did I get this thing? God damn, this is really a companion, this guy. It has been helping me quite a lot during this video. Because I need to confirm that the way the assembler and the compiler handle the instructions. Yes, but I'm in 64-bit mode, man. Mod, okay, immediate value 8. Okay. Then for the rex prefix opcodes a source register and displacement of 24. Okay. So now let me try to have this lit and lit end lit begin and then lit begin here, and let me do the same stuff, but I want to find out. Okay, so this is where the literal is it goes at the end. So it's very easy to patch it actually. It's very easy to patch it. Right? So like to patch my little I just need to write it at the end. Right, those are the questions. Let me just, yeah, sure. I just want to also confirm that this is going to work in all platforms, like, or in different assemblers, because, yeah, the assembly code is not, that, yeah, this is this way. Portable, yeah, it's not that portable. Rex prefix, so 64-bit mode using R13. Be the opcode for, yeah. Is it true that if I patch the literal in that place, it is always going to work for x86-64 independently of the OS slash assembler version like GCC or Clang, etc. I just want like to have some sort of confirmation that this is true. Yes, it's specific that. I just want to make sure that the assembler does not create. Generative work regardless. Okay. So we found a way to have dynamically. It just took me 1 hour and 27 minutes to solve the issue that I thought about at the beginning of the episode. So we found a way to dynamically patch a block of code, right? And yeah, so here we can receive like an int 64t or something, like it doesn't matter, like so, and we can receive the literal, right? And then to patch this block of assembly, we just need to firstly we can use memcopy, it's fine. It wouldn't have been actually needed, but well, it's fine. We can go to the literal end, right? Take the address, subtract the size of this, right? Of int64. Can we do that? Yeah, we can do that. And here, oh yeah, we need to can I patch the codes? So if I do that, and then here I just say this literal is in fact a char pointer, and I just do it. Is this even a thing? Well, let's try out, right? So if I execute, so if I do this, this should be 0 initialized at the beginning, writing 8 bytes into a region of size 0 overflows the destination. Why is this region size 0? So is it because of these parentheses? Or should I, will I need to cast it into a void pointer? Probably I need to cast it into a void pointer. I need to do something like this, like casting magic. Yeah, I need to wrap all of this. That. It's still complaining. So if I cast it there, are you going to complain to complete object type? What are you even talking about? So if I do something like void star dst equals this, and then I do dst minus equal this, are you telling me that this... Okay, yeah, of course, yeah, I know what you're talking about. So if I do this, are you going to throw a... Okay, you are no longer throwing a warning. So that was the issue. So if I extract this into a variable, you no longer complain, apparently. Okay, okay. And basically this is going to copy 8 bytes, the 8 bytes that compose the literal, right? Basically. Does this matter? If this comes from a register, does that... probably not. Probably it's fine. So now it's 0, and if I call lit, right, this code should execute, and it should fill it with whatever literal I pass here. Fuck, I got segmentation fault. Oh yeah, of course, because I probably cannot write directly into the codes. But I should be able to write afterwards, right? So this doesn't really... Well, we'll think about it. But this basically... Yeah, we get the block. We need to patch the block at yeah, +2. We are going to assume that it is +2, right? Because... oh no, it's more than that. It's 1 2 3 4 5 6 7 8 9 10. So it's basically size minus that. That's size of int 64. And then we have a literal, and we can have... yeah. So let's have the literal here in 64. So if I have the literal here and let's say 42, we can cast that. Sure, here we can do size of literal, right? We can extract this into a variable just to be slightly cleaner. This is the destination. We get the block size minus that. It makes total sense. So we are patching the assembly code that we... fucking hell, it's still not work. Why are you not working? That's very strange. So let me print the following. If I print dst minus, or actually block minus dst... no, not really, the other way around. dst minus whatever is the block, and I comment this shit, right? What am I going to do? I'm going to 10, which is the correct size. So why are you throwing me... is it because I do this kind of shit? It's probably because I do that kind of shit. So I basically need... what do I need? I'm so tired, fucking hell. So fix this code to patch the instructions block. I am getting set false. I'm not casting it correctly. But why I'm not... Oh, fucking hell, of course. I'm so retarded. Jesus Christ. Yeah. I'm so tired. I need to... Yeah, of course, it's okay. But it is still... Oh, yeah, but it filled... So this finished at 49dp. It filled 2a. So 2a... I assume 42 in x is 2a, I presume. Yeah, it's 2a. So if I get like a larger number, it's going to fill out more, but okay, it's finally working. So yeah, let me think. Let me think. Let me think what I want to do. Well, let's do it, right? Let's actually do our thing. So we are basically going... Let's try to push a little. So let's bring back what we had. Here, do we need this? Yes, we do need this. What is the difference between that and the other thing? Oh, I see. So that's why you need that kind of shit. So here, I need to use this in order to have those kinds of operands and all that shit. I see. So let's try to add that again. So this is the... Do I remember? Output, I don't think... Yeah, this doesn't have output. Then input operands doesn't have... Then this is what the interest is. As like the clovers. And this was R12 and R13, right? Something like this. And here is the same shit. Fill with clovers in here and whatever it's needed. Okay. I'm fucking... I'm so tired. Okay. But let's just try to have like a literal being pushed by the dynamically generated assembly code at runtime. This... What the fuck is a CC? Does it explain? Refers to the condition codes which are updated by some instructions. Okay, it makes sense. So they both do that shit. Okay. Yeah. Okay. So let me try one thing. I forgot. Can I change this? Can I change this directly? So can I... Well, but is that going to even make sense? Maybe. Let me think. So if I do... Where was it? Here. It was something like end -8, basically. So if I do that -8, and I do this, so ignore that, and I do this before, yeah, it doesn't... So it needs to go into the... Okay, it needs it to be like this, I guess. This is exactly what I want. Okay. Yeah, it doesn't allow me to do that. So I cannot pass the value here, right? I cannot pass it here. And so I need to patch it afterwards. Okay. So we can basically have enforce what what is the name given to built-in words. I don't know if force has like a very specific name for this kind of shit. Primitives. Okay, we can call it primitives. So this is primitives. Primitives, right? This is how we write it. Yeah. So this function is going to hold all the primitives, like so. And it's not supposed to be called, right? We just want to make sure. Well, I can add a comment. Not supposed to be called. It just holds the code for all primitives, right? Something like this. Primitives is not supposed to be called, it just holds like so. I don't even, well, how do I want to comment? Shit. Yeah, no point of punctuation, it's fine. Cool. So now let's comment this for now and do the following. So now we need to create a memory region for the code, right? For the codes. For that we need to use mmap, right? Because there is none of that in the standard lib. And mmap is inside system mman. Okay, let's do that. This is going to throw, I need to like initialize VS Code from within the WSL, but whatever. So here I need to do mmap an address, a new mapping individual address space. I don't really care about the address, it can be anywhere, right? Or I can like mmap this starting address for the new mapping is specified in address. I could use like, yeah, I could use the starting address 0. Why not, right? So we create a memory region for code that starts on 0. I mean, we can change it if it's needed. Then the length. Length for now, let's say, I don't know, 1 page. Okay, we can clean this afterwards, which must be greater than 0. That's fine. If address is null, then the kernel chooses the page align address. Okay, so if I pass null, it chooses any page. Fine. This most portable method, perfect. Then the protection, the mapping episode using length at set. Okay, so we basically need the prot argument. We need this prot exec, right? So we need to execute shit, and we need to write into it, right? Do we need to read from it? I don't think so. I don't think so. So then we need flags. What are the flags? Map shared. Share these mapping updates to the mapping are visible to process. It depends. Do we want? Maybe we'll have multi-threading in the future, but for now, I guess we can do map private. Are not visible to other processes. The same file and are not carried through to the underlying file. File call are visible to the mapped regions. Let's do private. Okay. Then I need, we have other stuff in here. We have flags and FD and offset. Okay, let's go to FD. Oh, there are other stuff. So map private, map 32-bit, doesn't matter. This might not be picked by any file. Its contents are initialized to 0. Oh yeah, this is maybe it's not by backed. Yeah, we don't want it to be backed by files. So maybe we just want to do this support. Then deny writes. We need to write this flag is ignored. Ignored. Is used. Okay, we can use that for stacks. Fine. Map use table. Map doesn't care. Okay, I guess that's basically what you want. There's a bunch of stuff, but they don't specify. Oh, the offset. Let's say the offset is 0. Okay. Cool. So what's the return? It returns a pointer to the mapped area on every map fails is returned and error no is set to indicate the error. Okay. So this is basically our code block, right? This is basically our code block. We can call it codes. And here we need to assert that codes is not equal to this stuff, map failed. Okay. So if we write this, if we execute this, is it going to even work? Too few okay, I'm missing arguments. So, oh, it needs fc. What is even the fc stuff? Did they describe? After map calls as returned, the file descript fc can be closed immediately. But I don't want the contents of file mapping as opposed to anonymous mapping. See, initialize using length bytes starting at offset. Refer to by the file descriptor. Okay, but I don't. Let's search for this. So map anonymous. This one is not backed by file. Its contents are initialized to 0. The ft argument is ignored. Okay, so it's ignored. We can just pass 0. Cool. Oh, I forgot to close. Yeah, finish that. We need to include a cert like this. Why are you okay? It failed, so we need printf. Let's include error no in that case. We can just print that and str error no. Invalid argument. Fucking hell. Fix this. Oh, I don't want to even think about this, to be honest. So it's null protect exec prot write prot private. Is it negative? What the fuck? Oh, p. The fuck are this? I swear to God. This Clanker. I am getting this shit. So, well, we can go back to it and what? Okay, let's do whatever it's telling us to. This is still going to fail, but or I'm basically extremely tired. Yeah. Still invalid arguments. Well, let's search for a stack overflow. So mmap executable memory in C. Sure, but so here they say, oh, they use get page size, which is a very interesting thing. So yeah, but I don't want. Yeah, this is just for reading. But am I not using? Oh, I fucking hell. I need map private. Okay. I thought I had already added it, but it apparently didn't. Okay, it's working. So we have now the block of memory that is executable. Now we basically need to get the next word. Right, next word. Let's assume that's that. And we need to do the following. So let's assume I'm going to input a number. We can assume that. Let's, in that case, do the following. So string number. Then I need to traverse. Well, I can copy that code from here. I know I did it quite often. So it's probably, yeah, it's here. I can copy it, yeah. So here is the num. And then I need to push this literal, right? So what can I do? Let's do this. I can have this as a global variable. This can be initialized like that. And here, so this is where, like, the table of primitives, like where I define all of the primitives. But now I need helper functions to help me do this kind of shit, to copy the data, right? So what can I do? I can do this lit, and here I can provide my literal, right? Let's say X. I can provide my literal here because now oh, I'm going to, yeah, I can call it lit, it's fine, because now I'm going to do the following. Mem C, what is the difference between mem cpy ccpy? Oh, okay, mem cpy to code. The source is going to be lit begin, like so, and then the size is basically just lit. Oh, I deleted that code, but I think it was something like this, right? The pointer to that stuff minus the pointer to lit ends. I think it was that. I probably still have that code in here. So that's one good thing about Clanker, is they help you. Yeah, okay, but they casted the, okay, let's do that. They casted it to sharp pointers, blah blah blah. We can do that. Just fancier. And to be honest, I could calculate this in the main function and just keep reusing like lit size. It would be nice, but I can do that in the next episode. So mem cpy. Then I need to do other stuff. I need to grab that, or I can do it in a separate call. I need to grab that, and then I need to do what I did before, right? I don't have the code. Okay. So to code, I need to add size and subtract size of x, right? Exactly. And then the source is going to be the char pointer of x, and the size is going to be size of x, right? And this is going to patch the number. Yeah, I think that's basically it. And here we must not forget to add the return instructions, right? And but this is like, am I going to need this? So if I call a dupe as is, yeah, I'll need to call this address. So yeah, I can keep that. And here the literal is a different case, because the literal needs to, it needs, yeah, to be put into code. Huh. That's interesting. Let's add it like a red for now so I don't forget. But we need to study that more. All right, but anyways, we did this. We did this. Yes. I also need, well, let's put the red above like this. So we assume this is a function. Let's assume this is a function for now. But in that case, code, yeah, that case, we need, fuck, to patch it is going to be harder. What the fuck can I do? Let me think. So I still, well, we can just append return x inst x86 64 x. We can just append it there, because now this function will need to return a pointer to the function that we just defined, right? So this needs to that like so, and here we just need to patch it a little bit. X86 64 red value. Man, I just need to return C3. Okay, so in that case, we basically just need to go to code size, so 0, yeah, and assign it, not this, actually, 0x C3, like this. So this is the right to do. I need to add to do to check what the fuck I want to do with this. And then we need to increment this by size plus 1, because we just added one instruction, right? And one instruction is like, this is literally 1 byte. Something like this. And so the next instruction I execute is going to put the code, is going to write code into a different place. Exactly. So here I assume I get a word that is just a number. I convert the number into an integer. And now if I call lit with that number, this is going to return me a pointer to the function. Let's call it func. That is literally machine, like compiled into machine code, right? And this function will always push this literal into the stack. And now I just need to call this. I could do something even better. I could do the following. I could say type def. This is a void function with no parameters, and it is basically I can call it function. This is a function, and here I can return a function. I think this is correct. This, yeah, I suppose. And basically this is a function, and then I just need to call this function, right? I call this function, and I can call it a few times just to make sure everything is fine, right? And then I can like print some elements of the stack just to like to be able to see what the fuck is happening. Let's say 10. Right, so it's going to print the first 10 elements of the stack. Here I just say printf like that, and stack I, and then printf like this. So if this shit works, okay, it's not a function. Yeah, I'm doing it probably in the correct way. Is that how you define? I'm not doing this correctly. Does it need an extra parenthesis? Fuck. Type def function that returns void, and it does. Oh yeah, I remember. It's this one. Yes, exactly. I remember now. Okay. The reference of a void pointer. Yeah, this can be a char. This is because this is always going to be that, and in case here we actually want word instead of string. We can cast it into function. It's fine. Cast it. Let's try again. Okay, no warnings. So if I say if I put the number 42 here, fucking hell. Oh my god. Okay. So, but why? Where exactly did it go wrong? Was it here generating, or was it here calling? Let's try to do that. Say something like this, and this is a bunch of bees. If I'm able to push something into the fucking stack today, it's going to be okay. So it was okay, so it was calling. Was it on the first call? Okay. Let's ask the Clanker. I'm so fucking tired. I'm so fucking tired. I am getting seg faults when calling func. Find the issue. Since the stack does not have, why doesn't it have? You need to push a return s onto the stack before calling func. What? Huh. So you're telling me that when I finish. Yeah, I don't care. So I don't get it. So let me print whatever is in code. we can say this char pointer start, right? Let's say this start, and then we can say code is equal to start. So we can have like an actual handle on that. And here I0 and I is less than code minus start I plus plus. Let's try to print that. Actually HHX, right? I think it was this one. And here we can just say code I, and yeah, let's print a new line at the end. If I do 42, it didn't print anything. What the fuck? Oh yeah, because I first need to call this stuff. So I need to compile the literal. Everything is 0. That's very sus. Oh, here, yeah, I need to do this. 42. Okay. So yeah, I can even detect this. So this is 42. That yeah. So the both memory has the correct instructions. Why am I getting set false? Right. This is, maybe it's like some protection issue or some issue that I'm not seeing. Like, goddamn. Sure, I just want an explanation. Initialize R13 to 0 before calling func. Initialize the top of the stack is correctly set. Why is that important? What? What are you even talking about? If I do this, yeah, it's still crashed. That ends with the issue. Is it like something main m project? What is this? Maybe some. Let me try it, I guess. So if after I define that, let me just do this. So this is start, then this is 1024 times 4, and the protection is prot exec. No, it's still, so it's not an issue with protection. That's not the issue. That's not the fucking issue, Jesus Christ. Other stack cards, what's that called? when I did, but yeah, so if I do, how do I execute code without calling function? Um, like that. So that's, is it because, no, it's fine. It's function pointer, that's function. Hmm. It says, so when I called this shit, if I have something like this, so void function, I don't know, hello, which literally just says printf hello. Well, yeah, I need to first check one thing. Do I still have? No, I don't. Let's just comment this. I need to check if the error is like in here or actually in the function. Oh, no, it's not, because this succeeded, right? It's failing. Yeah, it's failing there. So if I do this and I say that, okay, my function is equal to hello, like that, this didn't crash. Okay, it didn't crash. Do I need to write assembly? Do I need to literally say something like, so I have that, this is my void pointer code, right? Or actually, yeah. Do I need to say call and what, how do, yeah. I need to do something like this, and then that, and then that, and then this is not a register, but I'm going to assume it works, and then calls, and then this doesn't do anything. If I do that, and then I exit with 0, what? Where did I? Oh, it's not here. It's here. Sure, let's comment all of this shit. It still gets segmentation fault. But why? So if I don't do this, and my code literally just as, so that is equal to this. If I literally just do this, yeah, am I still going to get? No. So there is some fucked up thing in here fucking up everything. Okay. So if I don't patch anything, if I don't patch it, well, yeah, I need to, so let's bring back this. So let's just test with this for now. It is, okay, so there is something in the copy that's fucking this up. There is something in the copy that's fucking this up. Huh. So for now, let's comment all of this. Let's do this and say this is equal to that, and then increment code afterwards. And yeah, so we actually need to, well, what the fuck did I do here? Oh, I see what the fuck. Oh my god, I found it. God fucking damn it. Oh my god, I'm so fucking stupid. Jesus Christ. So this is the results, or this is the start. You can call it start. The start is the current code pointer. Then, fucking hell. So this is the current code pointer. Then we do all of the shit we need, and then we need to return the beginning of the fucking function. God damn. Let's say this is the beginning. Okay. Is this going to work? Yes. Fucking hell. Oh my god. Oh my god. So this is a function. I don't need this. This can be commented out. I don't care. This is not needed. This is not needed. So just a single line of code and I fucked up everything. Jesus Christ. Like 2 hours and 70 minutes and I'm still not finished with this. God damn. Okay. Undefined func, because here we want func. Yeah. If I do 42. Okay, it didn't do, oh, because yeah, we need multiple of them, because the stack doesn't have like the first value, it has like the second value. 42. Okay, so this one pushed to the top of stack, and then this one kept pushing, so this one basically pushed to R13, and this one kept pushing to the stack, right? So now finally, once and for all, we are capable of compiling at least literals into machine code and execute that machine code dynamically during runtime. So this is basically a JIT compiler. This is how more or less a JIT compiler works. Of course, like a JIT compiler doesn't compile everything. We are going to compile everything to machine code. There's not going to be a single piece of code that's going to be run like during a single piece of code that's going to be run in a VM, right? So everything is going to use like the native CPU. But yeah, very interesting, very interesting. So if I change like the num, I can change the num dynamically, right? I can say if I do all of this shit, then it's going to print my stack. Very interesting. Okay, so there is one last thing, like if I input something here, right? I don't want to keep constantly appending stuff to my code. So this code segment is going to be for functions, like for codes, like for literally for functions, right? So one thing I can do, right, is to basically say, well, but that needs to be dynamic. Fucking hell. Huh. So I will most likely need two versions. I'm trying to avoid having two versions of lit. Let me test one thing. So if I have, so this is lit 0. Let's say this is lit 0. And if I have lit 1 for now, so this is a literal which only contains assembly. right? Like this. And if I do that bullshit that they were telling me to do, with like the int 64, and I say this, and then instead of having this here, I just do this, and here I do the, what was it? It's not a register, but okay. R, and I provide N, right? If I do this, what's the code segment going to look like? That's a very, yeah. So this lit, oh, this is lit 0. Well, actually, yeah, let's do this. So lit, this is not going to return anything. I just want to print this stuff. For size t, I equals 0. I is less than this stuff, and yeah, I can extract it here. Size I plus plus, and then I can do for actually print f. Well, I can move it. I can move it for now, just to be simpler. And here I want the HHX that at this position, right? Well, I don't actually need to move it as long as I assume this is that casted into sharp pointer, and then I just index it, right? So if I do this, and here I don't care about that, and I can have it stuck. If I do this, operand type mismatch for move apps. Okay, so we need to go to here, and we need to read more about input operands. Okay, so fucking hell. Jesus Christ. I just want, so here they used what's the difference between R and equal R? Oh, I can call it, okay, I can say this by, okay, so I can say something like, if I do this thing, like N, and here I can say N, is this going to work? And if I, okay, but it doesn't like it. So it does not like it. Should I simply use it without? M, what the fuck is M? They don't even describe this shit. A memory input like M. Let's try M. So here, I just say 0, and here you can say M. Operand mismatch. Yeah, because this needs to be immediate, right? This needs to be immediate. This is for risk 5. Okay, so we cannot do that. Exactly. Well, but we can... Huh. Like, let's see. One more try with the Clanker. See. By 64-bit immediate value type, which may not be 60. What are you even talking about? Oh, so I need to use N instead of M. Is that what's... Well, there is difference. ASM. Impossible constraints in ASM. Okay. So let's see what it says now. I think this is not really possible because... Yeah, but let's see. Maybe I'm wrong. Oh yeah, so I need to do this. Well, 64-bit immediate value, but it seems that the compiler is unable to satisfy this constraint. Yeah, of course. Change the constraint from NR to choose a register for the operand, which can be used with to specify the immediate value. Is it even going to work? Yeah, it's not going to work. Oh yeah, I need to do that. So illegal immediate register operands. Yeah. Let's just try one more time, but I don't think this approach is going to work. So what we can do is like a scratch pad that we just keep using to execute these kinds of shit. I for immediate. We can try that. We can try it, but I doubt it's going to work. Yeah, it's not going to work. It's just hallucinating stuff. So one thing that we can do is to simply have this shit like this, like we had before. And yeah, so we can just do the following. So we keep these primitives here, right? We keep them here. And when we want to execute something at compile time, or like at evaluation time, instead of doing that, we can reuse this stuff. So we'll, yeah, let's have like a, because I want to share the code, right? I don't want to have one implementation for one instance and another implementation for another instance. So let's have this code and let's have another code stuff, but this one is going to be like a scratch pad. Scratch pad. I think it's properly written. Let me just confirm. Yeah, it's properly written. And it's going to be exactly the same. This one is going to be code start. And then I need another one for scratchpad start. And this can be a page as well, because the OS is going to allocate a page either way, so it doesn't matter. And then my lit function basically just needs to accept the target, right? So it needs to accept the destination of the code that we are compiling. So we can have destination like this, and this is the pointer. So this is the beginning, right? Something like this. So we begin that, then this is all the same. Here we need to use destination, and then that's that, and here we return begin. Okay, so this now it is capable of doing that. So here, when we call it, let me call this type of func. It's easier. So if I call this func, and this is basically going to be my f, right? Then I can call my function, but here I need to provide the destination, and it's going to be the scratch pad, right? So, and when I do this, I can basically reset my scratch pad always afterwards, right? And then I can just execute stuff. So this should be another better approach. So if I do that, yeah, it works. So basically, why do I need a scratch pad? This is for like immediate evaluation, and this one is for like compiled functions or compiled words, right? So this is persistent, and this one is temporary, right? So that's the difference. I need to find a better name for this one. I don't know if Forth already has it, but yeah. So here I will always need to include this shit. So why not just move that? Well, but yeah, this is fucked. Because if I'm inside, I cannot do this shit. Because if I'm inside a function, I want to have multiple words inlined. I don't want to be constantly calling, right? So I just want to copy this and inline it inside the word body, right? But if I have like an eval during like the one that I have here, that I'm literally instantly evaluating the number and executing it, I need to have this return because I'm calling this function individually, right? So I don't know. I need to think about this stuff. Yeah, I need to think about this stuff. I'm gonna keep it like this because I've been recording for a very long time. 2 hours and 33 minutes is a very long time. But yeah, the next episode we'll think about it. To have like a way to both persist code into like a block and evolve like and this is basically for colon definitions. So let me just give you an example. So this is basically for when I say this and I have words and then I loop swap and I return. So this is basically for this kind of behavior, and this one is for the behavior where I instantly swap, right? So those are two things are different. I could force the user to always define like a main function, like an entry point, like C does, because C forces you to define an entry point. So you cannot have like arbitrary evaluation of code here, right? You are forced to evaluate code inside the function. Yeah, but yeah, I'll think about it offline. So this was a very long session. I was not intending it to be so long. I started like at 8:30 p.m. It's like already like almost 11:30 p.m. So I need to go to sleep. But yeah, it was quite productive. We were actually able to figure out how to JIT compile numbers in Forth, which is extremely powerful because now this shit is super optimal, right? We don't need to evaluate bytecodes VMs and stuff like in a VM and all that shit. We just literally execute the machine code. All right, so that's everything for today. Thank you for watching, and I see you in the next one.